Hello friends. Today I am going to discuss about integrals. This is one of the important topic for board and JEE mains, CET or all competitive exams. This is a very important topic. Integrals. Integrals. Integral calculus is motivated by the problem of defining the calculating areas of region bounded by the graph of the function. So actually integral calculus arises from the solving two types of problems. Solving two types of problems. Which are the problem of finding function whenever its derivative is given. The problem finding function. Finding a function whenever its derivatives is given. To find the which function's derivative is, to find the real function for the given derivative function. And the second one is find the area bounded by the curve. Finding the area. Finding the area bounded by the curve, by the graph of the functions, by the graph of the functions. Graph of functions under the certain conditions. Under certain conditions. So the integral calculus is used to find out two different cases, two different areas. One is the problem of finding a function when its derivative is given. And second one is find the area bounded by the graph of the function under certain conditions. For example, if you see the example for case 1. So that is also called as an antiderivative. So cos x. This is the derivative function. So which function's differentiation is cos x? That is d by dx of sin x. So we get the cos x from by doing the differentiation of sin x. Sin x. So now this sin x is called original function. Sin x is called original function. So this also called as antiderivative. Is a real function. So therefore we call it as an antiderivative of cos x is sin x plus c, because derivative of constant is 0. So derivative of sin x is cos x. So derivative of cos x is 0. Similarly, if the function is given 3x square, which function differentiation is 3x square? That is, we can write as this one, x cube function's differentiation is 3x square. So here, sorry, an antiderivative of 3x square is an antiderivative of 3x square is x cube plus c. So these are the derivative functions are given to find the original function. In this case, we are using integral calculus. So we call it an antiderivative. Antiderivative of 3x square is x cube plus c. So now see that some second case. So we have the second case, finding the area between the bounded by the graph under the certain conditions. For example, there is a curve or there is a line. So we need to find the area bounded between the curves. At x is equals to a and this x is equals to b. We need to find this area. This we can call it as delta as dx. Dx denotes a small rectangle. Rectangles. A rectangular area. So we converted this into small rectangles. Small rectangles. Adding this total area, so we call it as summation, sum of that. So this is the curve, y is equals to f of x is a line or curve, a line. So adding this, that is summation f of x, which one you are adding the dx areas. So this summation can be symbolic form integration. That is f of x dx. From a to b, this is the symbolic form. So the area converted into small rectangles after adding this, so converted into rectangular form, then we will get that area between the intervals. Area between the intervals. So these are the second type of problems we are using that integrations. So first one is to find the previous original function of the given differentiation or derivative function. So that is called as antiderivative. Here second case is find the area between the curve or line between the curves. We are converted into small rectangles. That small rectangles is called dx. There will be some minute area that we can consider as, that is f of b minus f of a. It's minute area. So between the intervals, to find the area we are using that integrations. So these are the two applications of major applications of integral calculus. Now we'll discuss some so that is symbolic form of integration. What is the symbolic form of integration? That is integration f of x dx. It represents integral of f with respect to x. The meaning is integral of f with respect to x. With respect to x. F of x is integrand, X is the variable of integration. F of x is integrand. Integrand. And x is the variable of integration. Variable of or variable of integration. Variable of integration. So integrated means to find the integral value. Integrand means, what is the meaning of integrand is, or integrate is to find the integral. Find the integral. C is a constant, arbitrary constant. So integration a to b f of x dx is equals to capital F of x plus c, where c is constant. Sorry. F of b minus f of a. F of b minus f of a. So it is we call it as this a definite integral. Definite integral. Integration f of x dx is equals to f of x plus c. This is indefinite integrals. Indefinite integrals. There are two types of integrals. One is definite and another one is indefinite integrals. So definite integrals are used only when the limits are given under the certain conditions. Indefinite integrals is to find the previous function or some functions, integrating the function. Now we'll discuss few what are the geometrical representation of integrals. So geometrical representation of indefinite integrals. Geometrical representation or interpretation of geometrical interpretation of indefinite integrals. Suppose y is equals to x square and y is equals to x square plus 1, y is equals to x cube plus or x square plus 2 plus and so on. These are the functions are given. To draw the graph of these functions, we get to draw the graph of these functions, this is y is equals to x square and y is equals to x square plus 1 graph will be and y is equals to x square plus 2 graph will be and y is equals to x square minus 1 graph also, or y is equals to x square minus 2 graph. If you draw a graph of these functions, all parabolic functions, parabolas, and you draw a straight line at x is equals to a. At x is equals to a. The equation of line is x is equals to a. x is equals to a. This is the point x a. So the point of intersection of this graph, it makes a tangents. This is one tangent. 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 So these are the tangents. These all tangents are parallel to each other. These all tangents will be parallel to each other. Parallel to each other. Parallel to us. So therefore, the different values of C will correspond into different representation of family of curves. The different value of C, if f of x is equal integration f of x dx is equals to f of x plus c. Integration f of x dx is equals to f of x plus c. Where c is the different values corresponding to different members of family. So these members can be obtained by shifting any one of the curve parallel to it. These are parallels. These are all parallel. These tangents are parallel to each other. Parallels. All tangents are parallels. So therefore, the geometrical interpretation of this is the indefinite integrals. The tangent at y is equals to the tangent all the curves at the point of intersection of the curve is parallel. These are all parallel. So these all tangents are parallel to intersection of that point. So what you can say that here tangents are parallel at that point. Tangents are parallel at x is equals to e. At x is equals to e. Tangents are parallel at x is equals to e. So this is the geometrical interpretation of indefinite integrals. Now discuss some properties. Properties of indefinite integrals. So first one is the process of differentiation and integrations are inverse of each other. The process of differentiation and integration are inverse of each other. For example, d by dx of integration of f of x dx is equals to f of x, and integration of f dash of x dx is equals to f of x plus c, where c is arbitrary constant. Arbitrary constant. So now we'll take this. Let capital F be an antiderivative of or any antiderivative of f. That is d by dx of capital F of x d equals to dx is equals to capital F of x. D by dx of capital F of x is equals to f of x. Now integration of f of x dx is equals to capital F of x plus c. So therefore d by dx of integration f of x dx is equals to d by dx of capital F of x plus c, that equals to small f of x, small f of x. So therefore f dash of x is equals to d by dx of f of x, integration of f dash of x dx is equals to f of x plus c, where c is a constant. So differentiation and integrations are inverse of each other. Now see the second property. Two indefinite integrals with the same derivatives leads two indefinite integrals. With the same derivatives leads to same family of curves. They are equivalent. For example, they are equivalent. Also, they are equivalent. That is, let f and g are two functions. Let f and g are two functions such that d by dx of f of integration f of x dx is equals to d by dx of integration of g of x dx. If you take inside that d by dx of integration f of x dx minus integration of g of x dx is equals to 0. Therefore, integration of f of x dx minus integration of g of x dx is equals to c. Some constants. Therefore, integration of f of x dx is equals to integration of g of x dx plus c. If you transfer right side. So therefore, both are equal. So from this we can say that integration of f of x dx plus c, integration of f of x dx is equals to integration of g of x dx. Next is, third one is integration of f of x plus or minus g of x dx is equals to integration of f of x dx plus or minus integration of g of x dx. This is also important property to split the function. Next one is integration of k times of f of x dx is equals to k into integration of f of x dx. So these are the properties of integration, the indefinite integrals. Now we'll discuss some problems, exercise problems. Exercise. Okay, before going to discuss that exercise problem, so what is the comparison between integration and differentiation? Comparison. Comparison between differentiation and integration. So both are operations of functions. Both are operations on functions. Both are functions. Both are operations and functions. It means that it satisfies that all operations about functions. Both satisfy property of linearity. Both properties are both satisfies are both functions. Both satisfies both satisfy both satisfy the property of linearity. Linearity. That is d by dx of k into f of x is equals to k times of d by dx of f of x. Integration of k into f of x dx is equals to k times of integration of f of x dx, etc. Similarly, where k is a constant. All functions are not differentiable functions. We know that all functions are not differentiable functions. All functions are not differentiable. Similarly, all functions are not integrable. Not integrable functions. All functions are not differentiable and all functions are not integrable. We will learn more about non-differentiable functions and non-integrable functions in higher studies, in higher classes. The derivative function when it is exists, it is unique solution. Fourth one is the derivative function. The derivative of a function when it is exist or when it exists, it is a unique. It is a unique function. It is a single function. Even the integration of the integral function is not so, but is not so. But the integral function is not so. So it will be different, that is. So these are the properties. So finding the primitive or finding the some physical quantities, derivative is used for some physical quantities. Some physical quantities like velocity of moving particle, when distance traveled at any time t is known, when distance traveled or when a distance traveled at any time t is known. Integration is also used to calculate the distance traveled when velocity of time is known. Integrations or integrals in calculating the distance traveled when velocity at a time is known. When the distance traveled when the velocity at time is known, at time t is known. So these are the properties of the comparison between differentiation and integrations. Now we'll discuss that some important formulas in differentiations and integrations. Already we know the differentiation formulas. With the help of differentiation formulas, we'll write that integration formulas. Integration formula or integrals or antiderivatives. Or antiderivatives. So integration of x power n dx is equals to x power n plus 1 upon n plus 1 plus c. N is not equals to minus 1. So integration of 1 dx is equals to, or dx is equals to x plus c. So integration of e power x dx is equals to e power x plus c. Integration of a power x dx, a power x by log a plus c. Integration of 1 by x dx, log mod x plus c. So this is part 1. Algebraic integration, algebraic exponential, everything. Now we'll see the trigonometric functions. Integration of sin x dx is equals to minus cos x plus c. Integration of cos x dx is sin x plus c. Integration of secant square x dx is equals to tan x plus c. Integration of cosec square x dx is equals to minus cot x plus c. Integration of tan x dx, this by using substitution method. This formula we can find by using substitution method. Integration of tan x dx is log mod secant x plus c or minus log of cos x plus c. So integration of secant x, cot x. Integration of cot x dx is log mod sin x plus c or minus log mod cosec x plus c. By using substitution method, we can find this tan x, the integration of tan x. So tan x can be written as sin x by cos x. Take denominator as t, we will get log x. So log x means function is cos x, so it will become log of minus log of cos x. By using substitution method, we will prove these formulas. Integration of secant x dx. Integration of secant x dx equals to log mod secant x plus tan x plus c. Integration of cosec x dx. Cosecant x dx equals to log mod cosecant x minus cot x plus c. These formulas by using substitution method we can prove that. These formulas are derived from using substitution method. These formulas are derived from using substitution method. So these are the trigonometric formulas. Now we'll go for inverse trigonometry based problems, formulas. So integration of 1 by root of 1 minus x square dx is sine inverse x plus c. Minus 1 upon 1 minus x square dx is cos inverse x plus c. Integration of 1 by 1 plus x square dx is equals to tan inverse x plus c. Integration of minus 1 by 1 plus x square dx is equals to cot inverse x plus c. Integration of cosecant x or secant inverse x. Integration of 1 upon x square root of x square minus 1 dx is equals to secant inverse x plus c, and integration of minus 1 by or 1 by x square root of x square minus 1 dx is minus cosecant inverse x plus c. So these are the inverse trigonometry formula based, inverse trigonometric functions based problems. These are integrals based problems, trigonometry based problems. You should be thorough these formulas. If you know that formulas, you can solve that integrations easily. So totally depend on these basic formulas. So I request you all this, be thorough these formulas. Now we'll solve that some exercise problems. Exercise 7.1. Exercise 7.1. Find the antiderivative of. First one is find an antiderivative of or integral of the following functions. Of the following functions. First one is sine 2x. Sine 2x function is given. So antiderivative means to find the original function of sine. Antiderivative is to find the original function. So here what is given? Sine x is given. We know that derivative of sine x is what? Which function? Differentiation is sine x. So that is cos x. Sin x function is, the derivative of sin x is cos x. So cos x is the antiderivative of sin x. Cos x is the antiderivative of sin x. Now what is there here? We have sin 2x is given. So this can be written as d by dx of cos 2x, that is minus 2 sin 2x. So we need to find the original function. If this is the given derivative function. So from this sin 2x is equals to minus 1 by 2 into d by dx of cos 2x. So therefore the antiderivative of sin 2x is minus 1 by 2 into half into cos 2x. So we need to find the original function, that is the antiderivative. It defines the original function. So now let us take one more example. A second problem is integration. So cos 3x. Cos 3x. So we know that d by dx of sin 3x is equals to cos 3x into 3. So from this, cos 3x is equals to 1 by 3 into 1 by 3 times of, or 1 by 3 into d by dx of sin 3x. So therefore, the antiderivative of cos 3x is 1 by 3 sin 3x. Now see the third problem. We have third problem, e power 2x. E power 2x. Similarly, we know that d by dx of e power 2x is equals to 2 e power 2x. From this, e power 2x is equals to d by dx of half into e power 2x. So therefore, antiderivative of e power 2x is half into e power 2x. Half into e power 2x. Now let us see the fourth problem. Ax plus b whole square. Find the antiderivative of ax plus b whole square. So the differentiation of ax plus b whole cube is 3 times of ax plus b whole square into a. That is ax differentiation. From this, ax plus b whole square is equals to 1 by 3a into d by dx of ax plus b whole cube. So therefore, the antiderivative of ax plus b whole power 3 is equals to 1 by 3 times of ax plus b whole cube. Antiderivative of ax plus b whole square is equals to 1 by 3 times of ax plus b whole cube. Now we have fifth problem, that is find the antiderivative of sin 2x minus 4 times of e power 3x. So we know that sin 2x. So d by dx of 1 by 2 cos 2x differentiation is minus sin 2x. Or we can take as d by dx of cos 2x is equals to 2 times of sin 2x dx minus, with the minus, because derivative of cos x is minus sin x. So from this, sin 2x is equals to d by dx of minus half into cos 2x. So therefore, antiderivative of sin 2x is minus half into cos 2x. Now second problem. We know d by dx of e power 3x is 3 times of e power 3x. So from this, e power 3x is equals to d by dx of 1 by 3 e power 3x. So therefore, antiderivative of e power 3x is 1 by 3 into e power 3x. So we have the problem, that is sin 2x minus 4 times of e power 3x. Antiderivative is minus half into cos 2x minus 4 by 3 times of e power 3x. So this is our final results of given function antiderivative. Just finding the original function, that is called antiderivative. So if given, this is the differentiation. When the function is given, differentiation function is given. When differentiation function is given, just to find the original function of given derivative function. So that is called the antiderivative function. Now we have 6, directly find the integrals. So integration of 4 e power 3x plus 1 dx, which, so make it separate, integration of e power 3x dx plus integration of 1 dx. So from this we can write as e power 3x is e power 3x by 3. Integration of 1 dx is x plus c. Since e power ax dx is equals to e power ax by a plus c. Difference, remember that if the function e power ax, but x coefficient is a, in differentiation just you are writing that a into e power ax in differentiation, but in the integration we will write by a divides by a. The x coefficient is write in denominator. So that is the integration of e power ax dx. Now 7th problem, integration of x square minus x square times of 1 minus 1 by x square dx, which implies integration of x square dx minus integration of x square by x square is 1. You can do cancel, that is 1 only. So now apply that, integration of x power n dx is equals to x power n plus 1 by n plus 1 plus c. By using this formula, applying this formula, we get x power 3 by 3 minus integration of 1 dx is x plus c. This is the final results. Now 8th problem, 8th one is integration of ax square plus bx plus c into dx, which implies, make it separate, integration of a into integration of x square dx plus b into integration of x dx plus c into integration of 1 dx. So a into x cube by 3 plus b into x square by 2 plus c into x plus c. So which formula is applied? The same formula, integration of x power n by x power n dx is equals to x power n plus 1 by n plus 1 plus c. This formula is applied. Now see 9th problem. We have 9th one is integration of 2 times of e power x square plus e power x dx. First to make it separate, friends. Just to make it separate, 2 times of integration of x square dx plus integration of e power x dx. 2 times of integration of x square dx. So which is integration of x cube by 3 plus e power x dx. So we use here formula, integration of x power n dx is equals to x power n plus 1 by n plus 1 plus c. Plus c. Now see the 10th one, integration of root x plus 1 by root x whole square dx. So apply a plus b whole square formula. So a square plus b square plus 2ab. So integration root x whole square dx plus integration of 1 by root x whole square dx plus integration of root x into 2 times of dx. Root x, root get cancel, square root cancel, square root cancel. So finally we will get integration of x dx, integration of 1 by x dx plus 2 times of integration of 1 dx. So which implies this is x square by 2. Integration of 1 by x is log mod x plus c plus 2 times of integration of x plus c. 2 times of integration of 1 dx is 2 into x plus c. So this is our final answer. Now we have 11th problem. Integration of x cube plus 5x square minus 4 upon x square dx. Integration of, make it separate, x cube by x square dx plus 5 times of integration of x square by x square dx minus 4 into integration of 1 by x square dx. So x cube and x get cancelled. We get integration of x dx plus 5 into x square cancel 1 dx minus 4 times of integration of x power minus 2 dx. Now apply this formula by x power n. Integration of x power n dx is x power n plus 1 by n plus 1. So this is x square by 2 plus 5x minus 4 into x power minus 2 plus 1 by minus 2 plus 1 plus c, which implies x square by 2 plus 5x. So this will be minus 1 become 4 times of 1 by x plus c. Since x power minus 2 plus 1 is minus 1, that equals to 1 by x. So this is our final result of this function. Now see that 12th problem. Integration of x cube plus 3x plus 4 upon square root of x dx. So integration of x cube by x power 1 by 2 dx plus 3 times of integration of x by x power 1 by 3 dx 1 by 2 plus 4 times of integration of 1 by x power 1 by 2 dx. Which implies, so 3 minus 1 by 2, so 5 by 2, it will become 5 by 2. Integration of x power 5 by 2 dx plus 3 times of x power, x can be written as root x into root x, and then root x denominator root x get cancelled, x power 1 by 2 dx plus 4 times of integration of x power minus 1 by 2 dx. So apply that integration of x power in formula. So from this we'll get x power 5 by 2 minus 1 by plus 1 by 5 by 2 plus 1 plus 3 times of x power 1 by 2 plus 1 by 1 by 2 plus 1 plus 4 times of x power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 plus c. So which implies, so this will be 7 by 2, that is 2 by 7. 2 by 7 into x power 7 by 2. This again 3 by 2 will get, so 2 plus 2 into x power 3 by 2. 3 get cancelled. So it will become now 1 minus 2 minus 1 is minus, so 1 by 2. So 8 times of x power 1 by 2 plus c. So this is the final answer. Go for now 13th problem. integration of x cube minus x square plus x minus 1 upon x minus 1 dx. Simplify the numerator by using factorization. X cube minus x square plus x minus 1 upon x minus 1. If you take the numerator x square common, x minus 1 plus 1 common, x minus 1 by x minus 1. That equals to x square plus 1 into x minus 1 by x minus 1. So get cancelled. So therefore the simplest form is x square plus 1 dx. Now integration of x square dx plus integration of 1 dx. So integration of x square is x cube by 3 plus integration of x plus c. So this is our final answer. Now 14th problem. We have 14th. So this is very important and repeated objective for board. Integration of 1 minus x into square root of x dx. First multiply this one, integration of root x dx minus integration of x root x dx. So convert the power form, x power 1 by 2 dx. This will be x power 3 by 2 dx. 1 plus 1 by 2, that equals to 3 by 2. Root is 1 by 2, x is power is 1. So adding that we will get 3 by 2. Now direct the formula that x power 1 by 2 plus 1 by 1 by 2 plus 1 minus x power 3 by 2 plus 1 by 3 by 2 plus 1 plus c. So simplify this one. So 3 by 2 it become 2 by 3. X power 3 by 2 minus 5 by 2 it become 2 by 5. X power 5 by 2 plus c. So this is final answer. So next one is 15th problem. So integration of root x into 3x square plus 2x plus 3 dx. So say multiply with root x. So integration of 3 times of. So 1 by 2 plus 1. So half plus 2 is equals to 5 by 2. So integration 5 by 2 dx plus 2 times of integration 1 by 2 plus 1 is. So 3 by 2 dx integration of x power 3 by 2 dx plus 3 times of x power 1 by 2 dx. So which implies 3 times of x power 5 by 2 plus 1 by 5 by 2 plus 1 plus 2 times of x power 3 by 2 plus 1 by 3 by 2 plus 1 plus 3 times of x power 1 by 2 plus 1 by 1 by 2 plus 1 plus c. So if you simplify this one, 7 by 2 it will become 2 by 7, that is 6 times 6 by 7 into 7 by 2 become 2 by 7. So 6 by 7 into x power 7 by 2 plus here is a 2 plus 5. So 5 by 2. So 4 by 5 into x power 5 by 2 plus so 2 times of x power 3 by 2 plus c. 3 get cancelled, we'll get 2 only. So this is the final answer. Now see the 16th problem. So this is also direct problem. Integration of 2x minus 3 cos x plus e power x dx, which implies 2 times of integration of x dx minus 3 times of cos x dx plus integration of e power x dx, which implies 2 times of x square by 2 minus 3 integration of cos x is sin x plus e power x plus c. 2 to get cancelled here. So x square minus 3 sin x plus e power x. plus c. So this is our final result. Now 17th problem. So we have integration of 2x square minus 3 sin x plus 5 root x dx. So 2 times of integration of x square dx minus 3 times of integration of sin x dx plus 5 times of integration of root x dx. Root x dx. So this will be 2 times of integration x square is x power 3 by 3 minus 3 times of integration of sin x is plus minus cos x. So minus cos x it becomes plus cos x dx plus 5 times of x power root x is that is x root x. So that is 2 by 3 1 by 2 plus 1 by 2 plus 1 dx plus c. 2 by 3 x power 3 plus 3 times of cos x plus 3 by 2 it become 2 by 3. So 10 by 3 x power 3 by 2 plus c. This is the final answer. So basic formulas only we are applying that. Now see the 18th problem. So this is very important for board one. Most repeated question. Integration of secant x into sec x plus tan x dx. You just multiply that. Integration of secant square x dx plus integration of secant x into tan x dx. Integration of secant square x is tan x plus integration of secant x tan x is secant x plus c. So this is the final answer. Now 19th problem is integration of secant square x by cosec square x dx. So better split this function into in terms of sin and cos. Integration of 1 by cos square x by 1 by sin square x dx. So this will be 1 by cos square x into sin square x by 1. That is integration of tan square x dx. So we don't have formula in terms of tan square x. So make it convert into integration of secant square x minus 1 dx. Convert the tan square into secant square x. Now integration of secant square x dx minus integration of 1 dx. Integration of secant square x is tan x minus integration of 1 dx is x plus c. This is the final result. Now 20th problem. Integration of 2 minus 3 sin x by cos square x dx. Here also make it separate that function. So integration of 2 into 1 by cos square x dx minus 3 into integration of sin x by cos x into 1 by cos x dx. So which implies 2 times of secant square x dx minus 3 times of tan x into secant x dx or secant x into tan x dx. So which implies 2 times of integration of secant square x is tan x, 3 times of integration of secant x tan x is secant x. plus c. This is the final result of the given problem. Now we have objectives, that is 21, the antiderivative of root x plus 1 by root x dx. Root x plus 1 by root x dx. We know that antiderivative means finding the previous function, primitive of that, primitive function. So root x is the differentiation of, or we can write directly, we can go for integration of x power 1 by 2 dx plus integration of x power minus 1 by 2 dx, which implies x power 1 by 2, 3 by 2 by 3 by 2 plus x power 1 by 2 by 1 by 2 plus c. So therefore this fraction is 2 by 3 x power 3 by 2 plus 2 times of x power 1 by 2 plus c. So direct integration, you apply that, you will get the same answer only. So here option C is the correct answer. You have 4 options, in that C option is correct. Now 22. If d by dx of f of x is equals to 4x cube minus 3 by x power 4, such that f of 2 is equals to 0, then f of x is, we need to find that. So here what is given, d by derivative of the function is given, derivative function is given. So from this f of x is equals to integration of 4x cube minus 3 by x power 4 dx. So it becomes 4 times of integration of x cube dx minus 3 times of integration of 1 by x power 4 dx. So 4 times of x power 4 by 4 minus 3 times of x power minus 3 by minus 3 plus c. 4 get cancelled, 3 get cancelled. So x power 4 plus 1 by x cube plus c. And what is given here? F of 2 is equals to 0 is given. So this is f of x now. F of 2 is equals to 0 means we need to find, we will get the c value. So that c is equals to 0. So sorry, c value 2 power 4 plus 1 by 2 power 3 plus c is equals to 0. From this 2 power 4 is 16 plus 1 by 8 is equals to minus c, or c is equals to minus 129 by 8. So therefore f of x is equals to x power 4 plus 1 by x cube minus 129 by 8. So this is the function when f of 2 is 0. When f of 2 0, then f of x is x power 4 plus 1 by x cube minus 129 by 8. So we got the option is, we have option, that is first option. Option A is correct answer. Option A is the correct answer. Even this also most repeated objective in board MCQs. So next we'll discuss next session. Thank you.